take a look here at what's called the intermediate value theorem. And with all the mathematical words and stuff, it states that if f is a function continuous on the closed interval a to b, and f of a does not equal f of b, and k is any number between f of a and f of b, then there is at least one number c in the interval a to b where f of c equals k. Now, I'm sure this is crystal clear just by reading it, but, in case it's not, we're going to take a look at what this is actually saying, because it's a really complicated paragraph here. And once we actually, show what this means, it's really more sort of a kind of like, you look at it and you're like, yeah, well, duh. Like, it's a really obvious thing that this is stating, but it's just presented in this way that's really kind of confusing sometimes. So let's take a look at what it's really saying. So up here, we're going to leave the same definition we had before of it, and we're going to go through on a graph what it's talking about, and see if we can explain it. So let's start out here. We know that f is going to be a function that's continuous on the closed interval from a to b. So let's pick a couple points here. Let's call this one a. Let's call this one b. And we're going to have some function between these two that's continuous on that interval. And the only stipulation here is that f of a does not equal f of b, which means whatever I pick for the value of y at a, the value of y at b must be different. So let's drop it down here. So these are definitely different points. That matches it. And this function is going to be continuous on that interval. So let's just scribble in here some continuous function. Can we draw it however we want? And here's our continuous function. All right, so the next part here, we've taken care of this. K is any number between f of a and f of b. So let's write some coordinates next to these points. So we know that this function, this point here, this is b, our x value is b. And whenever we want to find the y value, we just substitute that in to the function. So this would be f of b. And we can do the same thing up here. We'd have a as our x value, and then our function here is f of a. And what we're told here is that k is a number between f of a and f of b. So k is going to be a y value that is between the y value here, the y coordinate here, and the y value or coordinate here. So let's just pick an arbitrary thing here. We'll call this height right here from the origin up. This is k. And this is telling us we have all this set up. Then there is at least one number c in a to b where f of c equals k. So somewhere between a and b, doesn't say where, doesn't matter where, is going to be a point c, such that f of c equals k. And what this is really saying is that if we have this value of k, whatever k is, there's some x coordinate, or c we're going to call it, so that x coordinate gives us k. So if we drop down to here, we'd say that this one here, right here, would be c. And we can see in this case, f of c equals k. We substitute c in, that's our x coordinate, to our function, it would spit out our y coordinate, which is k. So now we've got a graph of this. And all this is saying is it doesn't matter what we pick for k, as long as k is between f of a and f of b, there will always be a value for x that when we run it through the function will give us that value for y. Now, if we look at this with a little, like we think about it a different way here, we have our graph and we have 2 points here. Call this a, f of a, and anywhere that's at least the y value is not the same as that one, we can take this one here, b, and f of b. This is basically saying that you cannot connect these points because it's a continuous function unless you hit every single value for y between these 2 points. So you can think of it as any value of y from here to here has to be represented. From this point to this point has got to be represented. And this makes a lot of sense. You can't draw a curve from here to here without somehow passing through all these y coordinates. It's impossible to do it unless you have a break in the graph, and then it wouldn't be continuous. So that's all it's saying, is to go from one height to another height, you have to hit every single height in between. And that's our intermediate value theorem.